right, so in this one, we're thinking back to that investigation that you did and how we've got two groups that we can say have the same structure even though they don't look the same. So notice this first group, we've got multiplication over 1i, -1, -i, and over here we've got our integers to 4, and addition mod 4. So I've got different results in my tables. Yeah? So on first appearance, they don't look the same. But what I see is that both tables, if we look across the diagonals, what I'm seeing is some symmetry. 1, 1, 2, 2, 2, 3, 3, 3, 0, 0, 0. Let's look over here. We've got 1, I, my negative ones, negative i's, positive ones, i's, back to -1. Yeah? 2 back to 2. If my 1 is like I, then I've got the same. My 0 is like 1. So I could explain in words how these have the same structure. I could also talk about the function. I've got to have some sort of function that's going to map these to each other. Yeah? So there is a bijective function. I could first just talk about how f of 0 would have to equal 1, f of 1 would have to equal I, f of 2 has to be -1, and f of 3 has to be -I. Yeah? So if I have this function, then I end up having exactly the same structure. So again, we could talk about that in words. The other way we can do it is to show that they're isomorphic by determining what the function is and then showing that our properties hold. So the first thing that we need to do is our function. Well, looking at these, I know that all of these values are powers of I. So if I have f of a equals I to the a, let's think about this. If a is 0, I get 1. If it's 1, I get I squared, -1, I cubed, -I. So I've got my function. All right. So this is our function. It's going to map from our integers, mapping to our set of 1i, -1, -I. Okay. So I've still got my two groups, and I've got my function. So now we want to show that f of a star b, so in this case our star is going to be our mod 4, because that's the one we're starting with, is equal to f of a blob. F of b, in this case my blob is going to be multiplication. So let's look at this. F of a plus b mod 4, f of a times f of b. Of course, our function f we've determined is this, so we're going to have I to the a plus b mod 4, I to the a times I to the b. And then this is just like the one we saw before. A plus b mod 4 is always going to have, this is different that we're not looking at our even odds, but our a plus b mod 4 is always going to end up yielding the same result in terms of powers of I as our a plus b is going to have. So we could say that this simplifies into I equals a plus b and I to the a plus b. So we've shown that our powers hold true. We also need to show that this function, or we need to talk about at least that the function is bijective. So remember, it needs to be a surjection and an injection. And we know that we're going to have all of our elements mapped. So we know that our 0, 1, 2, 3 is going to map to 1, I, -1, -I. So it's also a bijection. So we have shown everything we need to show for an isomorphism. Morphism.